Under the vast, silent canvas of a desert night, a small, unassuming creature embarks on an extraordinary journey. Across dunes and rocky terrain, it rolls its prized possession, a meticulously crafted ball of dung, in an almost perfectly straight line. For generations, the precise navigational tools of the dung beetle remained an enigma. How could such a tiny insect, often active in the dimmest light or complete darkness, maintain its course with such unwavering accuracy? The answer, as science would reveal, is nothing short of celestial. For the dung beetle, a freshly formed ball of dung is more than just sustenance, it represents shelter, food, and a nursery for its young. Competition for this valuable resource is fierce, making swift and efficient transport critical. Once a beetle has gathered its prize, the paramount goal is to escape the immediate vicinity of the dung pile as quickly as possible, minimizing the risk of theft or interference from rivals. This urgent need for a straight, unswerving path is the driving force behind its remarkable navigational strategies. Imagine navigating a featureless landscape, blindfolded, while pushing a heavy load. This is akin to the challenge faced by a dung beetle. Without landmarks, a straight path is the most efficient way to distance oneself from the source and avoid circling back into competition. But how does one maintain a straight line without a compass or visible horizon? For decades, researchers pondered this question, initially looking for cues in the immediate environment or the sun's position. The true answer was far more distant. Initially, scientists observed that dung beetles primarily used the sun during the day to maintain a straight course. Their sophisticated eyes are sensitive to polarized light, a pattern formed when sunlight passes through the atmosphere. This polarized light provides a sky compass even when the sun itself is obscured. At night, the moon was thought to serve a similar function. These discoveries illuminated the beetle's incredible ability to harness celestial cues, but a puzzle remained for the darkest, moonless nights. What about those nights when the moon is absent, or completely obscured by clouds? Deserts, though clear much of the time, still experience such conditions. And yet, even then, the dung beetles were observed to roll their precious cargo with remarkable precision. This persistence of straight-line navigation, even in what seemed like complete darkness to human eyes, suggested an even more subtle, yet powerful, navigational mechanism was at play. The solution required looking beyond the obvious brightest objects in the sky. To unravel this mystery, scientists devised ingenious experiments. They placed dung beetles inside a planetarium, a controlled environment where the sky could be precisely manipulated. By projecting various celestial patterns, or removing them entirely, researchers could isolate potential navigational cues. It was here, under an artificial firmament, that the truly astounding truth began to emerge. The beetles were placed in circular arenas, and their rolling paths meticulously tracked under different skies. The breakthrough came when the planetarium sky was set to mimic a clear, moonless night. Researchers were astounded to find that the beetles continued to roll in straight lines. However, when the faint band of the Milky Way was switched off from the projection, the beetles' paths became erratic and confused, circling aimlessly. This was it, the final piece of the puzzle. The humble dung beetle was, in fact, navigating by the diffuse glow of our home galaxy, the Milky Way. The realization was profound. Instead of relying on a single bright point of light like the sun or moon, the dung beetle was utilizing the broad, gradient pattern of light from billions of stars within the Milky Way. This diffuse band of light provides a stable, symmetrical cue, allowing the beetle to maintain its orientation. It doesn't perceive individual stars but rather the overall luminosity pattern, which acts as a reliable celestial compass, even when incredibly dim. How can an insect with a brain no bigger than a grain of rice perceive such subtle light? Dung beetles possess compound eyes, made up of thousands of individual ommatidia. While not designed for sharp, detailed vision like ours, their eyes are highly sensitive to low light levels and specific light polarization. This allows them to detect the subtle differences in light intensity across the Milky Way's band, interpreting it as a spatial cue to maintain their chosen direction of travel. The dung beetle's method of utilizing the Milky Way is not about fixing on a single star, but rather using the entire celestial panorama as a reference. As the beetle rolls its dung ball, it periodically climbs on top of it, performing a short dance or scan. This behavior allows it to take a quick reading of the sky, reorienting itself and correcting its course if necessary. This panoramic sampling of the sky, even if brief, is critical for maintaining its extraordinary straight-line path. Why is a straight path so crucial? Any deviation from a straight line would lead to inefficiency, wasting precious energy and time. In a competitive environment like a dung pile, circling back could mean losing the treasured dung ball or attracting more rivals. By swiftly moving away in a direct line, the beetle maximizes its chances of securing its prize and finding a safe, undisturbed spot to bury it. The Milky Way acts as an infallible guide in this vital mission. The desert floor is often riddled with obstacles, rocks, twigs, uneven sand. These can easily disrupt a beetle's path. If it were relying solely on terrestrial cues, it would constantly be diverted. However, by fixating on a celestial reference that remains distant and unaffected by ground-level disturbances, the beetle can correct its course after navigating around an obstacle, quickly returning to its original heading. The celestial compass provides an external, stable frame of reference. While this phenomenon has been studied in various dung beetle species across the globe, some of the most compelling research comes from the arid regions of Africa and Australia. These vast landscapes, with their clear, dark night skies and minimal light pollution, offer prime conditions for observing such celestial navigation. The abundance of suitable dung beetle species in these areas also makes them ideal natural laboratories for observing this extraordinary behavior in its undisturbed context. It's important to remember that the Milky Way isn't the only celestial cue the dung beetle uses. It's part of a hierarchy of navigational tools. During the day, the sun's position and polarized light are primary. On moonlit nights, the moon takes precedence. But when these brighter, more obvious cues are unavailable, the beetle seamlessly switches to the fainter, yet equally reliable, guidance of our home galaxy. This multi-layered approach ensures constant orientation, adapting to whatever the sky provides. The ability to perceive and interpret these celestial patterns speaks to an intricate biological compass mechanism within the dung beetle. It's not just about seeing light, it's about processing that information to determine and maintain a heading. Scientists are still working to understand the exact neural pathways and physiological adaptations that enable this feat, but the evidence clearly points to a highly refined and innate system designed for precision navigation in the most challenging environments. For millennia, humans too have looked to the stars for guidance, from ancient mariners charting courses across oceans to modern astronauts navigating the cosmos. The dung beetle's story reminds us that this deep connection to the celestial sphere is not unique to our species. It is a fundamental principle woven into the fabric of life, a testament to the universal power of celestial bodies to provide orientation and purpose, even for the smallest inhabitants of our planet. The discovery that dung beetles use the Milky Way for navigation offers a powerful illustration of the wonders present in the natural world. It underscores that even the smallest creatures are equipped with incredible abilities, perfectly suited to their particular existence. It's a profound reminder that there is always more to learn and appreciate about the intricate systems that allow life to flourish, often in the most surprising and elegant ways. The desert night, once a barrier, becomes a guide. As the sun rises, the nocturnal dung beetles will retreat to their burrows, their day's work of rolling and burying complete. But with the return of darkness, the cosmic dance will resume. Each night, under the enduring glow of the Milky Way, countless tiny navigators will push their treasures across vast deserts, guided by a celestial map billions of years old, a timeless testament to the hidden complexities and profound beauty of our shared world. A truly remarkable feat of orientation.